The second problem is going to have you calculate the radial velocity. So they told you on the worksheet that the galaxy part is pretty straightforward. V equals z times c, because you know what that z is the same thing as delta lambda over lambda. So you can just use the information from that column. So our constant was given to us in the handout, which is 3 times 10 to the 5th kilometers per second. If you're not as handy with your calculator, I would strongly suggest that you not try to put in the exponent, but that you just put in the zeros. So 3 times 10 to the 5th is the same thing as saying 3 with 5 zeros after it. And it just is a little bit cleaner that way, and that way you're sure you get the right answer. And that it's not a problem with the calculator. So in our first example that we were looking at in the first one, our galaxy NGC 1357, the z value that we have in our table was 0.007. That was from our previous example. Excuse me, so v equals z times c. We have 0.007 times 3 times 10 to the 5th power, which is the same thing as saying 2100, or 2.1 times 10 to the 3rd power. You don't have to put it back into scientific notation. You're welcome to leave it in long form. The last two on the table are not galaxies, they're quasars. And so we're going to look at how when you're calculating using a quasar, the formula is a little bit more complicated, but if you remember your general rules about your please excuse my dear Aunt Sally, you do your parentheses, your exponents, your multiplication, your addition, subtraction, and then you'll be okay. So we'll walk through it. So in this example, I just made up a number. This is not one of the examples from your table, so please don't put it in there. I made up a z value of 0.5. So if that were the case, our constant, we remember we got from our worksheets, that was 3 times 10 to the 5th. If 0.5 is z, I'm going to substitute 0.5 in everywhere there's a z. So it'd be 0.5 plus 1 squared minus 1, 0.5 plus 1 squared plus 1. So we put those in, and then so if we add those two together, so now we have 1.5 squared minus 1 over 1.5 squared plus 1, multiplying all of that. That's what these are for. The parentheses, the brackets should go all the way down, but I can't make it do that on the computer, sorry. So these brackets actually take in the whole thing there. So we're going to take this whole thing and multiply it by our 3 times 10 to the 5th. So when we square this number here, we get 2.25. So and that's the same on top and bottom. Then we're going to subtract 1 on the top and add 1 on the bottom. So we get 1.25 over 3.25. We took 2.25, subtracted 1 from it to get our 1.25. We took 2.25 and we added 1 to get our 3.25. Then we're going to do that division problem. We're going to divide 1.25 divided by 3.25 to get our 0.38. Now we can do our multiplication, and we can multiply 3 times 10 to the 5th times 0.38, which would give us 114,000, or 1.14 times 10 to the 5th. So like I said, this is just an example. What you would do is you would take the z values from the chart and you would plug those into the z, just like we did in here. But as I said, unless you're really good with your calculator, I would do the zeros here for the 3 times 10 to the 5th. Instead of trying to plug in 3 and do exponent times the 5th, just put in the 5 zeros. So put in for example, in this example, put in 0.38 and then put in times, and then put in your 3 and then put in 5 zeros and hit equals in order to get the right answer. If you're not as good with your calculator, you might have everything set up correctly, but if you plug it into your calculator wrong, the answer won't even be close. So I would suggest just using the zeros.